Hello, this video is for my Algebra 1 students. We're going to be doing a continuation of Lesson 8.2. We're going to be doing examples 4, 5, and 6 from the lesson on pages 334 and 335. As I said, it's a continuation of our lesson where they're talking about exponents, powers of variables, and how they change when you raise a power to a power, or you have a negative power, and also just what their instructions tell you how they want it done. I'm starting with example 4, bottom of page 334. It says divide these two numbers and express answer in positive exponential form. That means they want all of the powers of the variables to be positive. It doesn't mean the answer has to be positive. It just means all the powers have to be positive. So it has it in words. It says divide this by this. So I've shown it as a division sign. We're not going to do that. We're going to draw it as a fraction. Division means the numerator divided by the denominator. X negative 6, y squared, z to the negative 2 power. Let's go ahead and get rid of this over here. Here it is rewritten. They want all of your powers to be in the numerator. Before we do that, though, we're going to take care of this 34 divided by negative 18. First thing we see is we have a positive divided by a negative. When we have a positive divided by a negative, that means our final answer will be negative. 34 divided by 18. 18 does not go into 34 evenly. Let's see what we can do. Well, they're both divisible by 2. If I divide 34 by 2, I get 17. If I do 18 divided by 2, I get 9. They don't share any common factors. 9 doesn't go into 17. So I'm left with negative 17 ninths as my coefficient of all those variables, the kind of the number part. Now we need to look at the variables. I have x negative 3 and x negative 6 on bottom. Best thing I would do, I wouldn't try canceling those, but any of these where you see a negative power, whether it's in the numerator or in the denominator, you need to move it. Anything in the numerator, you're going to move down to the denominator. Anything in the denominator, you're going to move up to the numerator. I'm not going to cancel anything yet at this first step. I'm just going to move things. So this x negative 3, which I have, I'm going to bring it down to the denominator. Oops. And when it moves, it changes sign. It goes from x negative 3 up here to x positive 3 down here. Likewise, this x negative 6 is going to move up, and it becomes x positive 6. By the way, if you put it way out here on the end, doesn't matter. It can go anywhere in here. The y squared. I said I wasn't going to cancel anything yet, so I won't. This z negative 2 comes up, and I have still the z5 that's already there, and now the z squared, which has moved up. Now let's cancel and do whatever we can. Still, the negative 17 ninths is the same. x6 over x3, well, 3 of those cross out, so I'm left with x cubed on top. Y squared and y squared completely cancel. And I've got z5 and z2, which gives me z7. There's the answer. I see that I copied it wrong. It's okay. Let's take care of that real quick. This was z negative 5. Let's just redo that. If this z negative 5 comes down, I have z5 down here, which that means this z5 was here. And the z squared and the z5, 2 of those cancel on top and bottom. And I'm left with z cubed here. I had it as Z7 there. There's the correct answer. It's a simple copy error. Now, I want to point out something. This question said put all of them in positive exponential form. The 3 is positive, the 3 is positive here on both the x and the z. It's not referring to this negative of the whole number at all. If it had said have everything in the numerator, which they will say that means that this z3 would come up and become z negative 3. So we would have negative 17 over 9 x3 z negative 3. That is if they said all exponents in the numerator. I need to point out that that does not mean that all numbers must be in the numerator. This 9 stays down in the denominator, whether they say have all your exponents in the numerator or denominator. Doesn't matter. They could have said put all exponents in the denominator, and that would mean all of these would move down. The negative 17 over 9 wouldn't change, but this x3 would move down and become x negative 3. This z negative 3 would move down and become z positive 3. I point this out because there are questions in the homework that they do this, and you needed to be aware of that because they don't give you an example like that. Here's the second example. It's actually example 5 at the top of page 335. It says, leave all exponents in the numerator this time. Whenever you have a quantity cubed, well, that's the same. This is 1 times 3 power, so we get y cubed. And the x squared is up there 3 times, x squared, x squared, x squared, or x to the 6th. Same with this 2. This gives me x cubed quantity squared, which gives me x to the 6th. Negative 4 times 2 gives me y to the negative 8 power. All right? Let's put this together all in one line. y3 x6. I'm doing this here. Y negative 8 over x6. This x to the 6th and this x to the 6th cross out. I can add the 3 and the negative 8 to give me y to the negative 5. I could have brought that y negative 8 down, have y cubed over y8. Here it is, everything's in the numerator. This is over the number 1. Y negative 5 over 1, which we don't have to have that 1. If they had said put everything in the denominator, or if they had said we want all your exponents to be positive, this would move down and become y to the 5th, but there would be a 1 left on top, and we'd have 1 over y to the 5th. Okay, so they can ask you for it in either form, y to the negative 5 or 1 over y to the 5th. The last example, actually there's 2 in example 6. It says simplify these expressions. Negative 2x to the negative 2 power, negative 3xy to the negative 2 over 12. Is it y squared or y cubed? It is y cubed. A lot going on here. You don't have to do this, but I'm going to put parentheses around this. Let's just take care of the numerator first. What is negative 2 times negative 3? It gives me positive 6. Here's an x negative 2 times an x positive 1. That'll just give me x negative 1. And a y negative 2 out there by itself. Over 12 y cubed. 6 over 12. That gives me 1/2. I'm going to run this out here. x negative 1. This y negative 2 jumps down and becomes y squared here, and we've got over y5. There it is so far. Now, some of my students have stopped here before, but they pretty much have a rule. And if they don't tell you where they want the powers, you got to have them either all in the numerator or all positive. It's not a rule, but it's something they go with. But what does this one say? They say they do want all the powers in the numerator. That means we should have brought this y5 up, where it becomes y to the negative 5. So I have 1/2 x to the negative 1, y to the negative 5. And as I mentioned earlier, just because they want all the powers in the numerator doesn't mean this 2 goes up into the numerator. It stays right there. Oh, you know what they didn't say? Boy, there's another mistake. Okay, they didn't say where they wanted it. So you could have them all here, x negative 1, y negative 5 over 2. Or if you wanted them all positive, you would bring them down and you would get 1 over 2 x to the 1, y to the 5. If they don't specify, then that's kind of Mr. Harrison's rule. Have them all in the numerator or have them all positive. Don't mix them up. Don't have both positive and negative in the numerator and the denominator. Okay? One last example. We're already at almost 12 minutes. I like to keep these videos short. This is example 6b. I hate to say this, but this is going to be a long one because there is a lot going on here. So we may be here a few more minutes. It doesn't say whether they want them all positive or negative. Let's just choose, and for right now we're going to make everything positive. So I'm going to move this z3 down. So I got 8x squared y z cubed. Now here's where it gets goofy. This negative 2 here, if you ever have a quantity to a negative power, there's several ways you can do this, but the first thing to do is flip it. That means flip everything inside the parentheses. I'm not changing any powers. I'm not changing anything from positive to negative yet. I'm just flipping the whole thing. So this is now going to be 2x to the 5th on top, y z to the negative 4 on bottom. And that negative, because I flipped it, has now become a positive power. That means everything in here gets squared. So I still have the 8x squared, the y z5, but 2 squared is 4. X to the 5th quantity squared gives me x to the 10th. Y to the 1 and 2, I get y squared, and I get z to the negative 8 power. I'm going to move up to there to that corner to finish this out. 8 times 4 is 32. X squared times x10 gives me x12. Y to the 1 times y squared gives me y cubed. Z5 and z negative 8 gives me z negative 3. One last step. Mr. Harrison has a rule, either all powers in the numerator or all powers positive. Okay? So the easiest way would be to move this z negative 3 up. So you would get 32 x12 y cubed, and I'm going to show this. This comes up and it becomes z cubed on top. If Mr. Harrison, if I had said everything in the numerator, this y cubed would come up also, and it would just be a y negative 3 up here. Either one of those answers would be acceptable. There you have it. Oh, I didn't tell you what your homework was. I'll tell you your homework on the printout. Thanks.